Hello everyone, my name's Dr. Vile and welcome to my A-Level Chemistry YouTube channel. The purpose of this channel is all about getting you ready for your A-Level Chemistry exams. And with that in mind, this video is going to focus on some of the inorganic tests, so testing for metal ions, testing for non-metal ions, and so on. It's not going to be exhaustive, but we'll cover some of the main ones, and perhaps I'll put together another video at another time that covers some of the other remaining content. If you find this video helpful, remember to like, subscribe, keep checking back for more content, as we're constantly updating this channel all the time. The first test that you need to be aware of is the flame test. Now this list here is from the WJEC specification for A-level, and for WJEC you need to know lithium, sodium, potassium, calcium, strontium and barium, and also that magnesium shows no colour because it burns in the ultraviolet region, so it sort of appears white. Now the flame test involves taking normally just a splint, wooden splint, and soaking it in a solution of the compound and then putting it into a blue roaring flame very quickly and just observing the color. You've got to take it out pretty quickly before the splint sets on fire. So if we look here for lithium, you'd expect to see a red flame color. For sodium, you could get away with either yellow or orange, so yellow orange. Potassium, the most acceptable answer is lilac. For calcium, you've got this sort of orangey colour here, orangey red. Then you've got strontium, which is a brick red. Barium, which is a apple green colour. And as we say, magnesium shows no colour, it appears white, it's burning in the ultraviolet region, not in the visible region. Just as a side point, the reason that we get these flame colours is that when you heat the metal, the electrons get promoted from a lower energy level into a higher energy level, and then they fall back down again, and the excess energy gets emitted as a photon of light. And the colour of the photon will depend on the energy gap between the energy levels. The next test that we need to be aware of is testing for a carbonate ion. So the carbonate ion is CO3 2-. So for instance, you could have a group 1 carbonate, which would be something like sodium carbonate. And you could have a group 2 carbonate, something like calcium carbonate. And on the left hand side here, I've got some rules that are helpful to learn. And the first key one here is that all group 2 carbonates are insoluble. So if you have calcium carbonate and you wanted to prove that you have calcium carbonate, or certainly a little test that will help show, is that it won't dissolve in water. Whereas group 1 salts are all soluble. So key difference here between sodium carbonate and calcium carbonate is that sodium carbonate will dissolve in water, calcium carbonate won't dissolve in water. But if we want to prove that we have, say it was sodium carbonate, to test that it's sodium carbonate, we could add acid. So a good test would be to add an acid like, let's just say, nitric acid, HNO3. And what would happen in the reaction is that you'd form sodium nitrate, you'd form carbon dioxide and water. And that would give you 2 lots of the sodium nitrate, therefore you'd need 2 lots of the nitric acid. Okay, and what you would see, very importantly, is a fizzing due to the presence of the carbon dioxide gas that's being produced. And to prove that it's carbon dioxide, you would bubble it through lime water, which would turn milky or cloudy. Another test that you can do is by adding sulfate ions. And once again, this could help distinguish between, for instance, sodium ions and calcium ions. So if you were comparing sodium ions and calcium ions, If you add sodium ions to sulfate ions, you'd form sodium sulphate, Na2SO4. And if you add calcium ions to sulfate ions, you form calcium sulphate. Now on the left hand side here I've got the list of the rules, and it tells you that the solubility of the group 2 sulfates decreases as you go down the group. So barium sulfate would be insoluble and calcium sulfate would therefore be fairly insoluble, whereas group 1 salts are all soluble. So by adding sulfate ions, this would dissolve, this would be soluble, whereas the calcium would be slightly more insoluble. So you might see a precipitate. So we can use sulfate ions to distinguish between group 1 and group 2 based on the idea that firstly all group 1 salts are soluble, but the solubility of the group 2 sulfates decreases as you descend the group. So beryllium sulfate would be soluble, but barium sulfate down at the bottom would be completely insoluble. Calcium, which is about halfway down, would be sort of soluble, but a little bit insoluble, so you'd see a precipitate. So we can use these rules here to help us solve problems. The next rule I want to focus on is this rule here, and that's the idea that the solubility of the group 2 hydroxides increases as you descend the group. So magnesium hydroxide is insoluble, barium hydroxide would be soluble. So going back to our question then, if you had, for instance, sodium ions, Na+, and you had, say, calcium ions, if you add hydroxide ions to it, in the sodium case, you'd form sodium hydroxide. Now we know that all group 1 salts are soluble, so this would be soluble. So you just get a clear solution. Whereas calcium ions would form calcium hydroxide, which would be less soluble. So you'd get a precipitate. You get a white precipitate. So sometimes you'll do a test and you won't get a positive result. It'll just look like nothing's happened, but you can use that information to help you. So for instance, if you add hydroxide ions and it's completely soluble, the product, so you won't see anything, you can still use that information to help you. Okay, so don't be surprised if sometimes you get negative tests when you're doing this kind of thing. Just because the negative test is negative, it doesn't mean it's not helpful. We can still use the result. Other test that we can use is the silver nitrate test. The silver nitrate test is testing for chloride ions, bromide ions, and iodide ions. And you add acidified silver nitrate to each. And that is basically a source of silver ions, so Ag+. Now these are all in solution, so these would all be aqueous. So if you have chloride ions, you would end up producing AgCl, which is a solid, it's a precipitate, and it's a white precipitate. Whereas if you have bromide ions, you would form silver bromide, solid, which is a cream precipitate. And if you have silver iodide or iodide ions, you'd form silver iodide, AgI, which is a yellow precipitate. And at this stage you might be thinking, well, white precipitates and cream precipitates are pretty similar. How could you distinguish between a white precipitate and a cream precipitate? The other follow-on test is to add ammonia. The silver chloride will dissolve in dilute ammonia, so it dissolves in dilute NH3. Whereas the silver bromide won't dissolve in dilute NH3, but it will dissolve in concentrated NH3. So dissolves in conc NH3. Whereas the silver iodide is insoluble in concentrated ammonia. Anyway, thank you for taking the time to watch this video. As I say, I hope it's helpful when it comes to looking at inorganic tests. It's by no means exhaustive of all the different tests that there are, but it is a good starting point when looking at inorganic analysis. If you found the video helpful, please remember to like, subscribe, share with your friends, keep checking back for more content. Thanks everyone.